Sometimes when we're factoring trinomials, it's important to check out and look for something common or some greatest common factors in the term. So when I look at this question, I can see that I've got 3, I've got 21, and I've got 30, and they all seem to have something in common to me. When I look at this, I'm thinking they've got 3 in common. And even before I go any further, I know that not only do they have 3 in common, but I also know that trick I said in class about if the first term is negative, we want to make that positive. So what I'm going to factor out of all 3 of these is I'm going to factor out negative 3, and negative 3 out of all 3 of these. So just like before, whatever I factor out, I write out first. So there's negative 3, bracket. So my negative 3's would cancel out here, so what I'd be left over with is x squared, and I know that positive 21 divided by negative 3 would be negative 7, and the x is left over, and I know that a negative times a negative makes a positive, so I'd write down positive, and then 30 divided by 3 would leave me with 10 left over. Now, once I've gotten the 3 out of this, I can factor what's inside these brackets. So like before, I'm going to take a second and draw my plus times table. I know I'm going to add to negative 7, and I'm going to have to multiply to positive 10. When I see this pattern that I'm going to multiply to a positive but add to a negative, you need to recognize that your 2 factors are going to be 2 negatives. Does that make sense? Or I hope it makes sense. So I start listing the factors of 10. So I've got 1 and 10 and 2 and 5. And I know that 2 and 5 are my factors because negative 2 minus 5 makes negative 7. So now what I can do is I can then take this and write it in as 3 bracket x minus 2, x minus 5. And now I have factored. Alright, so I'm going to factor this one completely using algebra tiles to begin. So I draw my table to start, and I've got positive 3 n squared pieces. So I'll draw a large square to represent my n squared, a large red square to represent my n squared, and another large square to represent my n squared. So n squared, and n squared. Okay, so the next thing I'm going to do now is I've got 11 n pieces, or negative 11 n pieces. So I'm going to start drawing them. So I'm going to just fill them in underneath here. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So far I've gotten all those pieces in, and the problem is as I look at this I realize it's not going to be a perfect rectangle, and I can't just take these negative 4 pieces and file them in there because they don't necessarily fit in there, and it's one of the properties of algebra tiles is that the whole pieces don't necessarily represent one of the variable pieces. What I could do is I could use the 0 pairs property, and I could bring in a 0 pair. So if I add in one more negative n piece to complete that, then over here I bring in a positive n piece, I now still have a total of 11 negative n pieces. So I've just used the 0 property, and now what I can do now is I can finish my rectangle and draw my 4 negatives, and so there's my, oops, wrong tool. There we go. So I'll draw my 1, 2, 3, 4, negative 1 pieces. So now what I'm ready to do is I'm ready to measure the lengths of my sides. So that is the length of 3 n's, and that's the length of 1 n, and it's a positive 1. This right here is the length of n, and this is the length of negative 4. So my overall answer in this would be equals 3n plus 1. Sorry if that doesn't look like an n at all. And n minus 4. There. the algebra tile method isn't something that works for you, we can still use our plus times table, and this is still possible to use. So what we can do is, the first thing we can write down is our negative 11 is still what we need to add to. So I'm going to take that negative 11, and I'm going to know that that plugs in right over here. So that's my negative 11 right there that I need to add to. But now when I multiply, it's a little bit trickier, and I need to take my a value and multiply it by my c value. So I need to multiply these two together. So what's 3 times negative 4? And I hope that you get the value of negative 12. So that multiplication is did. When you multiply those two together, you'll put them in right there. So now I need to look at this carefully and think for a second. So how do I multiply to make a negative? So to multiply to make a negative will require a positive and a negative to be multiplied together. The next thing I need to do is I need to think. Which one's going to be the big number? And this negative symbol right here tells me that the negative term will be the big one. So there's my big number. Alright, so now let's brainstorm the terms, or the factors, not the terms, but the factors of negative 12. Here we go. So we've got 1 and 12. I've got 2 and 6. I've got 3 and 4. And I know that this is going to be positive, 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 negative, negative, negative. All right. So what's 1 minus 12? 1 minus 12 is negative 11. So there is our factors. So now I'm going to do something called decomposing. And just forgive me if I delete things for a second. I'm going to try to delete something here. See if I can select it. That's really great. Whoa, I don't want to do that. There we go. We'll just delete that just to clean it up a bit. And I'm going to delete one more thing here. There we go. So we're cleaned up. So I'm just going to clean up, rewrite a couple things. So we had negative 11 here, and we had negative 12 here. And so just to kind of get that back in there. So we're going to do something called decomposing now. So to decompose, what we're going to do is we're going to actually break apart 11n. And I'm sure you will all agree that negative n is kind of made up of our two terms. So you can write it in either way, and I'm going to write it like this just for the sake of... And so you know that negative 11 is made of negative 12n plus 1, and you know that still equals negative 11n plus 1. Still really equals our negative 11n, and it's kind of like the zero out property that we did earlier. Or the zero pairs. Right, so now I'm going to factor. So what does this have in common? And we're going to factor by grouping here. So I can recognize that they have 3n in common. And when I look at here, many students will sometimes say, well, they have nothing in common, but they actually have a positive 1 in common. So I'm going to factor those out. So I'll write 3n brackets, so what's 3n squared divided by 3n, and that's going to be n. What's negative 12 divided by 3? That's negative 4. And then it's plus 1. And then it's n minus 4. Like I said before in class, if you have these two matching what's in the brackets, you know you're in a good place. And so I know I'm in a good place. I'm now going to factor out these common factors of n minus 4 and n minus 4. I then write n minus 4 because I've factored that out, and then I write what's left over, and so I've got 3n plus 1 are my factors. So I have this for us to practice, and I'll just kind of redo this for the sake of role modeling or showing. And so in this one, I'm going to start with my plus times table. So if that times looks a little wonky, I got positive 5 and negative 12. I know that if I've got a negative right here, I know that my two factors are going to be a positive and a negative. When I look and see that it's going to be a positive 5, I know my big factor is going to be positive. That's my big number. So now I'm going to say that this is my factors of 12 are going to be, oh wait, I made a mistake here. I forgot to do 2 times 12. And so what's 2 times negative 12? And that is, thank you, brain, negative 24. I can't fit that in there. Negative 24. There we go. So I need to figure out what multiplies to negative 24. So I can start with 24 and 1. I can say 12 and 2. I could probably even say 8 and 3 plus, minus, plus, minus, plus, minus. And I know that 8 minus 3 is going to be positive 5. So I'm not going to go any further. I could keep going and say 6 and 4, but I know that those are my 2 factors. So again, I'm going to decompose. So 5c can be made by saying 8c minus 3c minus 12, 2c squared. Alright, so, and it doesn't matter if you're panicking from the last one. It doesn't matter what order you write these in. I wanted to show you in the last one that you can factor by 1. So I can see that these have 2c in common. And this one has 3 in common. And this is one of those moments where you want to stop and think. See that if it's a negative right here, you want your first term to be positive. So let's just say 3 negative. Let's factor that out. So once I factor this out, I say 2c bracket, and 2c is what I've just factored out right here. 2c squared divided by 2c is just c. 8 divided by 2, or positive 8 divided by 2 is 4, and the c's are cancelled out. What is negative 3 divided by negative 3? And that would be just 1. So they cancel out, and you would get c. And what's negative 12 divided by negative 3? And that's positive 4. Again, I look at what's inside each set of brackets, and I know that I'm in a very good place because these match. So I'm going to divide by c plus 4 and divide by c plus 4, which equals, or factor out c plus 4, so I write c plus 4 brackets. What's left over? 2c minus 3 are our 2 factors. So I'm going to go all the way back to the start. And actually, I'm going to factor this one using the exact same technique we've been using. So in this one here, I'm not going to factor out the greatest common factor to start. So this is something that students do, and I want to make sure that I show you what to do here. So I'm going to start with my plus times chart. I know I've got to add to positive 21, and I know I'm going to add 2. And so what's a, and this is, be careful here, what's negative 3 times negative 30? And I hope that you get positive 90 from that. And that kind of helps you figure out what you're going to be doing here. So here we go. So I'll write down positive 90. Here we go. So now, what are our multiples, or how do we factor negative 90? And so when you have 2 positive, you know it's going to be a positive and a positive. So here we go. This might take me a bit here, and so bear with me. It's 90 and 1. Divides by 2, so it could be 45 and 2. It could be 30 and 3. I'm going to need my calculator here now, because now I can't just guess at these anymore. 90 divided by 5 is 18. So that's 5 and 18. Does 90 divide by 4? No, it doesn't evenly. Does 90 divide by 6? Yes, it does. And that looks like our match right there, 15 and 6. So if I said 15 plus 6, that does equal 21. So here we go. I then am going to decompose 21 into 15x plus 6x minus 30. And then this is negative 3x squared. So you can see there that I've decomposed now. And I think, what do these have in common? Yes, they have 3x, but we want to remember that rule about having the first term being positive. So let's factor out negative 3x. So, all right, negative 3x bracket, what's negative 3 divided by negative 3? 1, so they cancel out. And x squared divided by x leaves us with x. And then I go 15x divided by negative 3, so that leaves me with negative 5. My x's cancel out. Next, I look at 6x and 30, and I can factor out 6. 6 divided by 6 would, oh sorry, I need to write plus 6. So my 6's cancel out, leaving me with x minus 5. Finally, I'm going to factor out x minus 5 and x minus 5. So once I factor that out, I have x minus 5, and then I have negative 3x plus 6. Most students will then write that and think that they're done. But when you get to this moment, what is happening here is you can still factor something out of here. What you can factor out of that set of brackets is you can factor out negative 3 and negative 3 out of this. The term you're factoring out, to keep good form and keep with the way that we write something in root form, so we write our number first. So we'll write negative 3, what we factor out. Bracket x minus 5, and that came from right here. And then finally, I then do my factoring. So what's negative 3 divided by negative 3? Just 1, so I can write x. And then what is, I made a little mistake there. I'm just going to erase that if I can. There we go. What's a negative, sorry, what's a positive divided by a negative? That's a negative. And what's 6 divided by 3? 2. And I believe that is now factored properly and similar to our answer from the very start.